Here we go. Welcome to your quiz review. If you understand every question in this review, you will be golden on your quiz tomorrow. So, these first four questions, the only thing I wanted you to do is practice factoring. So, number one is the sum of two cubes. So, if you remember the pattern, we've got a small set and a big set of parentheses, and then we have SOP, SOP, same sign, opposite sign, plus sign. And what you do from there is you take the cubed root of 8, which is 2, the cube root of x cubed, which is x, and that's your first term. Then you take the cube root of 27, which is 3, and that's your last term. So when you're moving to the second set of parentheses, you square the first term, so 2x squared is 4x squared, and 3 squared is 9. And they go in the first spot and the last spot, just like in the first set of parentheses. Then this middle spot, all you have to do is multiply these two terms. So 2x times 3 is 6x. And that's it. You are done. The next example is very similar. It's just the difference of two cubes. So you're going to start small and large set. Same sign, opposite sign, plus sign. Cube root of x cubed is x. Cube root of 64 is 4. Square the first term and put it in the first spot. Square the last term and put it in the last spot. Multiply those two terms together and put them in the middle, and you are done. So that is the sum and difference of cubes. Number 3 is the difference of two squares. Because x to the fourth is a perfect square, it's not a cube. So what you're going to do is difference of two squares pattern. This is x squared minus 4 and x squared plus 4. But you have to recognize that that x squared minus 4 is also the difference of two squares. So this is x plus 2, x minus 2, and then x squared plus 4 stays how it is because there's no such thing as the sum of two squares. The last example is a grouping problem. This is where we group the first two and the last two. Factor out your GCF of the first group, which is x squared, leaving you with x plus 4 on the inside. Then you factor out your GCF of the second group, which is a negative 9, leaving you with an x plus 4 inside. Inside of your parentheses is the exact same, so we write that once. And then we use our GCFs and put them together. So that's x squared minus 9. You just have to recognize again that that is the difference of two squares. So the final answer for this problem is x plus 4. And then this becomes x plus 3 and x minus 3. And that is 4 different examples of factoring problems. Keep in mind, anything from first semester is still fair game, and always remember to look for the greatest common factor to be factored out first. The next section is solving. Now solving is still going to involve factoring, but after you factor, you're going to have to set every term equal to 0 and solve for a value of x. So in this first example, the first thing you need to do is factor out your GCF, which in this case is 2x. And that's going to leave you with a 2x plus 3 on the inside equal to 0. Now what you're going to do is you're going to take each term and set it equal to 0. So 2x equals 0 and 2x plus 3 equals 0. Now you solve both. So you have x is equal to 0 and x is equal to a negative 3/2. So remember, factoring out a GCF is still considered factoring, and that's how you do that problem. Number 6. What multiplies to a negative 8 but adds to a negative 2? And the answer to that is going to be a negative 4 and a positive 2. But what goes in front is a little different. This is x squared minus 4 and x squared plus 2. And that's because we're starting with x to the fourth and we're dropping to x squared. So it's still the same what multiplies to a negative 8 but adds to a negative 2 It's just your first term is going to be x squareds instead. And then you recognize the x squared minus 4 is the sum, or the difference of two squares. So we have an x plus 2 and an x minus 2. And this is an x squared plus 2. So from here, you're just going to set everything equal to 0. And you're going to get an x is equal to a negative 2, a positive 2. And with this guy, you're going to have plus or minus I root 2. And that's because you have x squared plus 2 equals 0, which is x squared is equal to a negative 2. And when you take the square root of both sides, remember you cannot take the square root of a negative, or we can call it an imaginary number. So that's how you do number 6. Number 7. That's another example of grouping again. So we're going to group, factor out our GCF of x squared here, leaving us with an x minus 2. And now we're going to factor out a negative 4, and that's going to leave us, again, with an x minus 2. So we have x squared minus 4 and an x minus 2. That's going to give us x plus 2, x minus 2, and another x minus 2. So x is equal to a negative 2 and a positive 2. There's no need to write the positive 2 twice. That'll take you back to a double root if we were to look at that graphically. Finally, number 8. X to the 4th minus 1. That is the difference of two squares. So that's x squared minus 1 and x squared plus 1. Remember, 1 is a perfect square. So this is going to become x plus 1 and x minus 1, because x squared minus 1 is a difference of two squares again. And that's going to give you x squared plus 1 because there's no such thing as a sum of two squares. Set everything equal to 0, and you get x is equal to a negative 1, positive 1, and plus or minus I. Again, for the same reason in number 6. You must set x squared plus 1 equal to 0, and you're going to subtract your 1, take the square root of both sides, and that's how you'll get your plus or minus I. Alright, moving on to long division. Long division, remember, is not the same as synthetic division. You actually have to show all work, and you have to use the x plus 2 and the x squared minus 6x plus 3. And what you want to do is you need to ask yourself, x times what is going to give you x squared? And the answer to that question is x times x. So it goes in your x column. Remember, you must have no skipping terms here, so you have to have placeholders. And then what you do is you just multiply. So x times x is x squared, and x times 2 is 2x. With long division, this is subtraction. So that's going to subtract, make that minus x, and that's going to make that a minus 2x. So those guys go away. Negative 6 minus 2 is a negative 8x plus 3. So ask yourself again, x times what gives me a negative 8x? The answer to that is a negative 8. Now you're going to take the negative 8 and multiply it to both terms here. So negative 8 times x is a negative 8x. And negative 8 times 2 is a negative 16. Again, this is subtraction. So minus a negative changes that to a plus, changes that to a plus. So these guys cancel. And we have 3 plus 16 is 19. And that is your remainder. So your final answer is x minus 8 plus your remainder of 19 all over what you're dividing by, x plus 2. That's long division. Now this last example is your big example. This is where we're going to put a whole bunch of skills together, where you're going to have to factor completely and solve, finding all the zeros, but this is going to require synthetic division as well. So this problem can be done in multiple ways, and it all depends on how you choose to do it. So I'm not going to show you all of your different options. I'm just going to show you one. Now, if you were to graph that in the graphing calculator, you are going to get a W of some sort, and it's going to cross the axis a couple of times. If you want to see exactly what it looks like, then go get your graphing calculator and type it in and find all 4 zeros if you would like. And then what you're going to need to do is you're going to need to pick one. And I'm going to tell you that one of those zeros is a -2. And there are 3 other zeros because remember this has 4 possible zeros. And what you're going to do is you're going to set it up 1, -2, -7, 8, and 12 because those are your coefficients of all of your terms in the original problem. So from here, what you need to do is use synthetic division. That's where you drop the first term no matter what it is, and you multiply -2 times 1, which is a -2, and you add these together. So a -2 and a -2 is a -4. Now you multiply again. A -2 times a -4 is a +8. And we add these together. -7 and 8 is a 1. Now we're going to do it again. -2 times 1 is a -2, which we add these together and we get 6. And one more time. -2 times 6 is a -12, and that gives us no remainder. So we end up with 1x cubed minus 4x squared plus x plus 6. So now what you think you're going to do is you think you're going to use grouping. But again, grouping will not work here. So you're going to have to use synthetic division again with this set right here. So what we're going to do is we're just going to use another big L. And we need to type that into the graphing calculator and find another zero we want to work with, which you would get 3. But I'm just going to pick 2. We're going to drop the 1. 2 times 1 is 2. -4 and 2 is a -2. And we're going to multiply that to get a -4. Add those together, we get a -3. 2 times a -3 is a -6. And no remainder, which is good. Now we have our x squared minus 2x minus 3. So from here, either it can be factored or it can't be factored and you're done. You would not need to use synthetic division again because once you get down to a trinomial, if it can't be factored by hand, it cannot be factored with synthetic division. Luckily, we have an x minus 3 and an x plus 1 because a -3 times 1 is a -3 and a -3 plus 1 is a -2. Now, the secret to success is you cannot forget about these 2 terms that you use for synthetic division. Those are part of your factored answers. So where did the -2 and the +2 come from? Where the 2 came from an x minus 2 and the -2 came from an x plus 2. And now you have your completely factored answer. That's what we need to see, all 4 terms. If you just would have written the purple part, you would lose points for not having it completely factored. And now to find all the zeros, all you have to do is set each one of these terms equal to 0 and solve. So you would have your x minus 3 equals 0, so x would equal 3. X plus 1 equals 0, so x is equal to -1. X minus 2 equals 0, so x equals 2. And the last one would be x equals a -2. And of course, if you would have looked at the graph with your graphing calculator, all 4 of those should have shown up as your zeros, again to prove to you that the graphs and factoring and finding zeros are all tied together. Okay, now this is a wonderful quiz review. If you can handle the questions that you just saw here, you should be great for your quiz tomorrow. So this is Longo, I'm out. See you, bye. Do good.